This is Jacob's Algebra, Chapter 13, Lesson 1. This chapter is about quadratic equations, and this first lesson is about polynomial equations. So when you see the equations 4x minus 7 equals 9, or 3x squared plus 4x equals 9x minus 2, or even x cubed equals 4x plus 2, these are all polynomial equations. They're polynomial equations because both sides of the equations are polynomials. Remember, a polynomial is a monomial of one or more terms. So these are polynomial equations. In fact, these are all polynomial equations of just one variable. Notice x is the only variable you see in any of these. You could have 3m plus 2 equals m squared. That's also a polynomial equation in one variable. If you have two different variables, like you say you have x and y both in the same equation, then it's a polynomial of two variables. But this is just, right now we're just working on polynomials of one variable. Every polynomial equation can be written so that one side of the equation is 0 and the other side is a polynomial of descending variables. Okay, so what you see on the screen now is a table that's in your book. This first column of the table tells the degree of the equation. In the second column, what you have is equations of different degree written in standard form. And then the last column is what the name of that type of equation is. So if your highest degree is 1, then it's a first degree equation. And the standard form of that equation would be some constant times x plus a constant equals 0. So we say ax plus b equals 0, and we call that a linear equation. The graph of that equation is going to be a straight line. Then we have our second degree row. Notice that our highest degree is 2, so it's second degree. Ax squared plus bx plus c equals 0, where a, b, and c are all constants. And that is called a quadratic equation. When your highest degree is 2, we call it quadratic. Remember, the title of this chapter is Quadratic Equations. So in this chapter, we're going to be dealing primarily with equations that are second degree. Okay, our third row in the table is degree 3. Notice the highest degree in our polynomial equation is third degree. We have our powers written in descending order. So we have ax cubed plus bx squared plus cx plus d equals 0. This is a cubic equation. A, b, c, and d are all constants. Then in our fourth row, we have the fourth degree version in standard form, which is ax to the fourth plus bx cubed plus cx squared plus dx plus e equals 0. A, b, c, d, and e are all constants. This is a quartic equation. And then, of course, in our fifth row, we have our fifth degree equation. Our highest degree is 5, ax to the fifth plus bx to the fourth plus cx cubed plus dx squared plus ex plus f equals 0. This is a quintic equation. A, B, C, D, E, and F are all constants. The standard form of a polynomial equation always has 0 on one side, usually the right side. And then we have a polynomial written in descending power order on the left side. Now you could have your 0 on the left side and have your polynomial of descending order on the right side, but that's not really standard form. In standard form, you have your polynomial in descending powers on the left side of the equal sign, and you have 0 on the right side. Okay, so let's work some problems from this section. When you look at problem number 4, it says write each of the following equations in standard form and tell the degree of the equation. So let's look at a couple of these. Remember, number 4 is just like number 8 that's in set 3 and that I assigned for homework. We're going to start with part C. Part C is x minus 1 times x plus 3, and that is equal to 2. Now, before we can write this in standard form, we have to multiply this out. Now you've got a lot of options for multiplying it out. I'm going to go ahead and use a grid because when I draw a grid, I always get everything multiplied out the way it belongs. So I'm going to draw in my grid lines. And then I'm going to write in x minus 1 on the left and x plus 3 on the right. Remember, you don't have to put a plus here. If there's no sign in front of the number or the variable, it's assumed to be positive. X times x is x squared. X times 3 is 3x. Negative 1 times x is negative x. And negative 1 times 3 is negative 3. When we add together what we have in our grid, we have x squared. 3x minus x is a positive 2x. And then we have minus 3. So that's what we have on the left side. And then we have equals 2. This is not in standard form yet. While the left side of our equation is a polynomial equation in descending order, our right side is not 0. We need to make the right side 0. How would we do that? By subtracting 2. But whatever we do to the right side of the equation, we have to do to the left side. So I'm going to subtract 2 on the left side as well. So on the left side of the equation, I have x squared plus 2x. And then negative 3 minus 2 is going to be negative 5. And that's going to equal 2 minus 2, which is 0. So now we have our equation in standard form. We have a polynomial in descending order on the left side, and we have 0 on the right side. Our highest degree is 2, so this is a second degree equation. So that's how we would answer part C. Let's do part D. Number 4D is 3x to the 5th is equal to x to the 5th plus 1. Now remember, we need to get everything, we need to get the right side equal to 0. So to get our right side equal to 0, right now we're adding x to the 5th and 1. So I'm going to subtract x to the 5th and I'm going to subtract 1. If I subtract it from the right side, that means I have to subtract it from the left side as well. So minus x to the 5th minus 1. So over here on the left side, I have 3x to the 5th minus x to the 5th. That is 2x to the 5th. And then I have nothing to subtract the 1 from, so that's just minus 1. On my right side, x to the 5th minus x to the 5th is 0. 1 minus 1 is 0, so I just have 0. This is written in standard form. It is possible for some of your coefficients in front of your variables to be 0. So if we go and look back at our first page, as long as your a is not 0, so long as the number in front of your highest degree is not 0, then any of the others can be 0. So let's go back to where we were. This is a 5th degree equation. Even though we don't have an x to the 4th or an x to the 3rd, x squared, or x, our highest degree is 5. So this is a 5th degree equation. Let's look at part E. So 4E. We have x squared plus 7x minus 10 is equal to x squared plus 10. So I want to get everything away from the right side. On the right side right now, I'm adding x squared and I'm adding 10. To undo that, I need to subtract x squared and I need to subtract 10. Whatever I do on the right side, I have to do on the left side because there's an equal sign. So I'm going to subtract x squared and I'm going to subtract 10. Notice I try and line these up with where the like term is on the other side. X squared minus x squared is 0. And then I have 7x. And negative 10 minus 10 is negative 20. On the right side, I have x squared minus x squared is 0. And 10 minus 10 is 0. So my right side is 0. This is a first degree equation. Even though we started off with an x squared on both sides, that x squared went away. So all I'm left with is a first degree equation because the x that is left is a first degree x. Okay, let's do one more from number 4. Let's do part F. Part F says x squared times 2x squared plus 9 is equal to x. Well, before I can do anything else, I have to multiply this out. I need to distribute this x squared across the 2x squared plus 9. X squared times 2x squared is 2x to the fourth, because when you multiply variables that have powers, you add the powers. And then I'm going to do x squared times a positive 9. That's going to give me a positive 9x squared. And that equals the x that's on the other side. Now remember, I want my right side to equal 0. Right now I'm adding x on the right side, so I need to subtract x on the right side. When I subtract it on the right, that means I need to subtract it on the left. So on my left side, I have 2x to the fourth plus 9x squared minus x. Notice I did not have an x term on the left side to subtract it from, so I just copied the minus x. On the right side, I have x minus x, which is 0. So now we do satisfy the requirements for standard form. We have a polynomial written in descending order on the left side, and we have a 0 on the right side. Our highest degree is 4, so this is a 4th degree polynomial. Okay, that was number 4, which is just like number 8 that I assigned for homework. Let's look now at number 5. Number 5 has a whole bunch of parts, so we're only going to do parts of this. For number 5, it says, tell whether each of the following numbers is a solution of the equation given by checking to see if it makes the equation true. So what you're going to need to do is plug in the value that you're given into the equation and see what it equals. If it equals the value that it's supposed to equal, then it's true. If it doesn't, then it's not true. So you're going to end up answering either yes or no, or you can say true or false. So I'm going to skip down to parts C and D, which use the equation 2x cubed minus 128 is equal to 0. So let's look at part C. For part C, we're going to say x equals 4. So I'm going to plug 4 into the equation in place of x. So 2 times 4 cubed minus 128. Well, what is that? So 4 cubed is 64. So this is 2 times 64 minus 128. And 2 times 64 is 128. So when we subtract 128, we get 0. That's what we're supposed to get because our original equation said 2x cubed minus 128 equals 0. That works because 0 is what we got. So yes, that works. This is true, or you can say yes. Let's try part D. For part D, we're going to use x equals negative 4. So we're going to plug this into our equation. We have 2 times x cubed, so that's 2 times negative 4 cubed minus 128. Okay, negative 4 cubed is going to be a negative 64. Remember, when you raise a negative number to an odd power, it's going to stay negative. If you raise a negative number to an even power, it's going to become positive. But this is an odd power, so our negative number stays negative. And then we're going to subtract our 128. 2 times negative 164 is negative 128. When we subtract 128, we're going to end up with negative 256. That does not equal 0. It does not equal 0, so this is false, or you can say no. Let's do one more example from number 5. Let's do from number 5, parts G and H. The equation is x squared minus 2x minus 2 equals 0. So we're going to start with part G, which is 1 plus square root 3. So I need to plug that into this equation, and I don't think I'm going to finish on this video. So 1 plus square root 3 squared minus 2 times 1 plus square root 3 minus 2. So that's our equation. I'm not going to be able to solve that in the time left on this video, so I'll actually solve that on the part 2 video.